is to present our paper of a patent quality classification model based on artificial immune system. And first, I have divided into these five parts to present our paper. Okay, the patent data is often not complete and full of noise, and its keyword search is not enough gainful insight from it, and the patent or the data has the text, image, and the lots of metadata, classification, codes, dates, and patent family structures, and external documents. And the traditional patent analysis requires spending much time, cost, and manpower. And the future patent recognition is a key research for present time because the patent effect on the industry and need to respond quickly. And the aim of the research is to develop an automatic patent quality classification model. Therefore, we collected the patent data of RFID industry from the database from Thomson Innovation, and we applied the artificial immune system to develop a classification model. And then we can predict the quality of a new patent by the proposed model to reduce the cost. And in literature review, some scholars mention that patent quality patent analysis can be used best for strategic planning, brand development, competitors and analysis, and oversee market development. And simply we use count the number of patents to measure the innovative ability of the countries, maybe mistake the rankings of the country. And patents are the status measures in legal rather than the economic meaning. And in the quality indicator, the primary patent quality indicators are related to investment, maintenance, and litigation. And legal status can show which technologies are hot and which are not for business intelligence. And the legal status information is patent is important in patent analysis. The high quality of the patent has the higher possibility to encounter patent litigation, and it will be important basis to measure the quality of patent. And immune system is a complex system, has a strong information processing characteristics such as the visual selection, pattern recognition, learning, and memory recall. And artificial immune system is derived from the mechanism of a biological immune system, fighting foreign pathogens. And using the AIS algorithm to find the best classification rule in in the category and set in the database to improve the classification accuracy. And AI is also used in collaborative filtering, and it is an advantage lying in the data reduction. And collaborative filtering is used for some recommendation system. And for example, we want to guess the user for it's like the item 3 or not. In general, there are two simple approaches based on collaborative filtering. One is the user-based, and another is the item-based. In the user-based, what the user 1 and user 3 like or not is similar, like the user 4, and both of them don't like the item 3. So maybe we can use the user 4 doesn't like the item 3. And in the item based, the item 4 will be considered as the collaborators of the item 3. And this is the framework of the proposed classification model, and including the two phases. One is the training phase, and the other is the testing phase. In the training phase, we adopt the context data of the pattern and select the 19 major indicators that are considered as the feature of the pattern. And according to these indicators, we apply the AIs to build the classification model. And the context data of the pattern split into data sets. And one is the training data set to building the classification model. And the other is the testing data set is to predicting the quality of the pattern and improving the prediction performance. And in our research, each pattern is considered as an integer, and a record of the pattern data in the training set is treated an integer, and the antibody is the integer which embedded the immune system. And we use the antibody to generate immune networks. And the left figure is the flow chart that how to generate and amplify the immune network. In order to generate the initial immune networks, we must to produce the initial network. And for example, we set the 3 initial immune network, and there are 9 purple points as the integer. And first, we randomly select a point. The point 7 as the first initial immune network. And next, we calculate the between the point 7 and the other points. We calculate the similarity with these points, and then we and because the similarity with between the point 7 and the point 9 is the worst, so we select the point 9 as the second initial immune network. And in the same way, the total similarity of the point 1 with 2 initial network is the worst. And the point 9 and 7 are the different classes. So the third initial immune network is the point 1. As mentioned, the ability is a threshold to decide a new antibody, is to be a new immune network or to clone amplify the related immune network. So the equation of the affinity formulated by Pearson correlation coefficient as follows. And for example, there are one antigen and 2 antibodies, and the affinity between the antigen and the antibody 1 is 1. And after generate the initial immune network, the immune network is involved by including the remaining antibodies in the system, and so as to amplify the immune network or produce the other new network to enhance the immune capability of the system. And as shown in the right figure, the antibody 2 is more similar with the immune network 7 than network 1 and 9. And the similarity of the antibody 2 and network 7 is larger than threshold. So the antibody will be cloned to the network 7 to amplify the network 7. The other is the following the same way to generate or amplify the related immune network. And this is the testing phase. And after immune network is developed, the pattern quality is predicted by the immune network. We set the set of the trained immune network with each consisting of the data set of pattern data. And here is G1, G2, G3 are the immune network, and the U2 with the U and R antibodies. And you want to predict the quality of the U1. And in this mechanism, we set 2 thresholds, which group and the pattern threshold both are 0.5. And first, we calculate the affinity of the G1 and G2, and G1 and G3. As shown in the table, the affinity of the G1 and G2 are larger than the group threshold. And so the G2 is the collaborator. And then there is only the U5. U5 has the similarity with the U1 larger than the pattern threshold. And so even the U2, U8, and U6 are also in the G2, but we just use the U5 to be the collaborator. And in our research, we collect the this patent data of the RFID industry from the patent data set of Townsend Innovation. And we split its patent data into 3 parts, and 2 parts are the training data set, and the other is the testing data set. And each patent data includes the 71 patent indicators, and we select the 19 major patent quality indicators as shown in the right table. And we use the impact legal status to define the quality of the patent. And and the others as the features. And when the impact legal status are larger than 3 times, we define the patent with the high quality, and otherwise is the low quality. And in the measurement, we adopt the accuracy and specificity and precision and recall to as the measurement. And in confusion matrix, there are 4 options. Let's repose the TP, FP, FN, and TN. And there are 4, and their definition as shown in the definition 1. And there are 4 measurements are evaluated as shown in the definition 2. And we have the 3 thresholds. The first one is to set the antibody, generate the new immune network, or clone it to the related immune network. And the second is to select which immune network can play roles of the collaborators. And the third is to choose the patent with high correlation. And the performance of the recall is approaching 87.1, and the precision is approaching the 97.8, and both of them are efficient. And it means that the model can provide the good classifiers and the patent quality indicators to predict the patent with the high quality. And the patent quality indicator play a role efficiently as the attributes in developing a classification model. And according to the experimental results, the proposed model can obtain the key information from the patent quality indicators to find out the patent with the high quality. And in the future, we will try to find the key attributes by data mining techniques, such as the feature selection or extraction. And thank you for your listening.
Okay, let's give a big hand to Ms. Chao. Yeah. Okay, thank you. Anyone has any question for?
Yes, but it is very interesting research, and
You don't need that.
you don't need that. I am interested in that if there is a new pattern discovered, then your system will be repeated whole system, whole learning or whole classification, or you just need to predict the new pattern, maybe just similar to the exist, and then you can classify more frequently. Which way will be the possible way in your system?
他的问题呢，she can understand properly. 就是说，如果有新的 new pattern, new one, not within your training set. In your training set, you have like 4,000 or 14,000, and then you do the testing, right? Testing based on your training data. Mr. John is asking you about what happens if you have a new data set, which is not within the training set. Okay. Actually, the testing data is not within the training set. Okay. But yeah, it might happen is once your system, the system cannot respond to the current newest IP, new pattern, which is just released and is not related to any previous one.
Okay.
Then probably we have to retrain. Yeah, that's what Mr. John is asking about. Probably we have to retrain the whole system or just partially. We don't retrain the whole system. We just retrain partially some data, close related, and using the AIS approach. What's your projection? 你觉得怎么样？
Maybe we will use the training data.
Yeah, actually, it's the very interesting question because currently the weakness of the machine learning. Machine learning is based on training data. Once the train like neural network, like AIS, any machine learning tool that's based on training data. And then we have a testing data. Then we have sort of 5-fold or 4-fold or 8-fold. What do I mean by 8-fold? We separate data into 4 groups. And the first group is for testing, the other 3 for training. And then the second part is for testing, and then the rest for training. That's the way we verify the algorithm. But what happens if any data is not within the system, which means you haven't yet training, because you got your accuracy is 98%, right? But what happens if new data not within this 10,000? Then probably your accuracy will decay, or even higher. We don't know. That's based on the relation. The relation between the new IP with the previous one. Yeah. So basically, once the neural network or the AIS is you feel your accuracy decay to a certain point, then you have to retrain everything again because the old training model, which is not responsive to the new data. Yeah. Interesting. Yeah. Okay. Yeah. All right. Then thank you. You are very brave. Thank you. As a PhD student.